to find dy by dx. Okay, so dx by d theta will give you minus a sine theta, and dy by d theta will give you b cos theta. So dy by dx is equal to dy by d theta by dx by d theta. So what we get here? We get b cos theta by minus a sine theta, which is nothing but minus b by a cot theta. What is this actually giving you? If we square and add, we get x square upon a square plus y square upon b square equal to 1. This is an ellipse equation which we studied in first year. This is an ellipse equation. Tangent equation at any point which we studied, any point P, a cos theta comma b sin theta, studied as x upon a cos theta plus y upon b sin theta is equal to 1. If we write the same equation in a slope-intercept form, y is equal to minus b by a cot theta x plus what we get is, when we write this one, this we'll get it as y is equal to minus b by a cot theta x and b by sin theta. b by sin theta. So this is equation. You can observe that the slope is minus b by a cot theta. Here also minus b by a cot theta. So it is also called as parametric differentiation. So x and y both are represented in terms of theta. Okay, theta is eccentric angle here. Theta is eccentric angle. So what we got is slope any point on ellipse which is represented in terms of theta is minus b by a cot theta. So b is a semi-major axis, semi-minor axis, and b is a semi-major axis is a semi-major axis is A, semi-minor axis is B. That depend upon the problem. Suppose B is bigger, then it becomes a semi-major axis. If A is bigger, then it becomes a semi-major axis. Other one will be semi-minor axis.